Hello and welcome to 5 Minute Math. Today we are looking for activities for TEKS 8.8c. This is modeling and solving one variable equations when you have a variable on both sides of the equal sign. So here are a few teaching videos, and what I'm doing is I'm walking through a blog post on my website, 5minutemath.net. I will put a link to this particular blog post in the video description. But just in case you need it, there are some teaching videos, how we can model one variable equations, how we can solve one variable equations. The reason I'm making this video and the reason I wrote this blog post is because the state of Texas did not do so well on this particular standard on the most recent STAR test 2023. Only 39% of the students were able to get this basic algebra tile modeling. And you notice it wasn't even a new item type, it was multiple choice. Here's a video explaining how to correctly solve this problem. And then this one was even worse, 25%. That's just basic guessing. The answer distribution for all four answer selections was really close to 25%, which means the students, for the most part, just guessed. They couldn't set up this basic algebra equation from a verbal description. Once you see the actual equation, it's a super simple equation to solve, but the problem is how do you convert it from a verbal description or a word problem into an actual linear equation that students can solve? So that problem is very difficult for students as well. So overall, our students really struggle with this readiness standard 8.8c. Here's a video showing how to solve that problem. The theory behind this is active playful learning. So I'm going to suggest some activities that we can do to teach 8.8c, but it's not a series of worksheets. It's not just watching more videos. We know that students learn best when they're active, when they're engaged, when they have meaningful work, when they're social, when they're joyful. There's a lot more about this learning theory here on this link. So this particular video is going to be placed right here in this blog post once I'm done in case you want to walk through. Let's look at our activities. The first activity idea here is called Roundtable. So what we're going to do is we're going to put students in a group of four, and I've got this example link. So let me just walk you through this example. So here is the example here, and this is the blank example if you wanted to use just your own, but I've also placed some verbal descriptions, four different ones, and these right here, if you read them closely, you're going to recognize them. These are released star question items. I just typed them out right here. And this is what the goal is. And I'll use this last one as an example. Students are going to be in groups of four. Every student is going to have a different problem, one, two, three, four. The first student, the first rotation actually, because every student's going to have their own piece of paper, they're going to take this verbal description and they are going to draw algebra tiles. Everyone does it on their own paper for a set amount of time. You can decide how long your students need. When the timer goes off, when you say rotate, every student rotates their paper one clockwise. And so now the student is going to get the next paper. So let's say the student gets the second paper. It's going to be this problem. They already have the verbal description and they already have the algebra tiles written from the previous student. So now their job is to work on this linear equation right here. So they take the algebra tiles and then they work on this linear equation, and then they create the linear equation. Then you rotate it, and then they get another problem, and it's got algebra tiles drawn, it's got a linear equation. They're supposed to solve for typically x. And so they do that solution, and then you rotate one last time. They are receiving a paper that's got algebra tiles, a linear equation, and a solution. They need to use substitution. Take the solution, substitute it back into your linear equation. Let's double check the work. Then you rotate it one last time. You're back to the one you started with, and you get to double check to make sure everyone did it correct. So that's a basic round table. The problem should get easier and easier, but there is that novelty that they are going to, work on a new problem each time, and they get to see what their students do. So here are just the written descriptions of those particular items of how we're supposed to do those. Here are some variations, right? If you need to, you can put students into smaller groups, so just groups of three. And then that third member, um, the first member would do the algebra tiles, the second member would do the linear equation, that third member could do both solution and substitution. So you could do different size groups if needed. If you need some additional scaffolding, right, you can start with half of the either algebra tiles or the linear equation cells already completed. So you don't want to necessarily do the whole thing, but maybe you can draw a key, or you can draw one side of the equation in the linear equation or the algebra tiles, and the students that are supposed to do these boxes might need to do the other half. And then when students complete their round table, students from the same problem. So let's say you've got 20 kids. Okay, so you're going to have 5 groups. Well, what you could do is you can have every student that had this particular problem, then they get together and then they all compare their work. Since they all worked on the same problem, they can compare, did everyone have the same visual representation with algebra tiles? Did everyone have the same visual representation in the linear equation? Did they write it the same way? Did they have the same solution? And so on and so forth. So you can extend it a little bit. So that's our first activity idea. The second one is called equation balance. So we're going to use gram stackers or other types of weights to represent one variable equations. And you are going to need some type of pan balance. So this might be available from a science lab or a science teacher. You want students to have no more than 6 in a group, so these can be slightly larger groups. You're going to borrow a set of balances and gram stackers or weights for each group. You want to split each group into 2 halves. And here's an example, right? We want to, and I've got this linked right here. Let me go and click over to it. What you're going to do is you are going to visually represent an equation, right? So let's take this first one for example. Okay, so 2 times 20. So I'm going to take these yellows are 20, right? I'm going to take 2 of the yellows and I'm going to take one of, and this green one is the 10, but what I suggest is a little piece of tape, maybe a post-it note. You're going to, you're going to cover that up. So, and eventually students are going to figure out which ones are which based on the color, but you're going to visually represent an equal sign, right? So that's going to be equal. Then you have 3 greens, right? 3 unknowns, plus 4 of these blue uh, 5s on the other side. And then obviously that equals, right? They both equal 50, but you want students to cover up the value that's in red. And then what you want them to do is write that equation. And then once they write that equation, um, they can have the one half does their one side, the other half or the other half of the group does, their other side. And then they get their gram stackers, they place it in there. And if they did it right, balances. And then what they need to do is, solve the problem, right? They need to solve for the unknown. But it's just a way to visually represent an equal sign, right? And the properties of equality and how equal, how you can find zero pairs and all that business. So here are some variations. You can ask students to create their own balance equations, cover up a value. So once they get the hang of it, they'll like creating a few of their own. You can have them verbally describe how did they solve the equation. So how did they know to take out zero pairs? So let's use some of that academic language. And then maybe they can have, and for those that have an extra challenge, I know it's not an 8th grade standard, but maybe they can create a 2 variable equation, 2 different types of weights or gram stackers covered up. And they can see if they can represent that maybe with an X and a Y, and can they solve it? So our third activity is called digital algebra tiles. It's probably something you might have already thought about. I've just listed a few different websites here, but we are going to need an online algebra tool, so I just use Didax. And really all we're doing, right, and if you're unfamiliar with these, right, you can kind of give denominations here, but I might say this green would be an X, and this red typically is going to, represent a negative X. Okay, so right now I've got, 2X equals negative X, and then I might add some, a constant here, so plus 3, and then we would solve for that. And that's all we're doing. We're just visually representing it. Um, you're going to need to display some type of linear equation if you don't not sure which ones to do. Obviously, you can use the ones from here. We're also going to have a few other ones displayed. They're just basic linear equations, and that's all they're doing. They're just using an interactive tool to represent it because remember, we had only 39% of our students able to visually represent this. If you want, there some of the other options. Let me just display those for you real quick. Right, so that was Didax. MathSpot looks like this. So you might want to vary it up a little bit because this particular representation actually had, the negative x and the 1, but sometimes you might not. Sometimes you might just have shaded and white, and then you might have a key. So it might be good for them to play with some options that actually have the values in there. And then you might want some like this that just have the colors, and you have to let them know, okay, red is going to be negative, and then anything other than red is going to be positive. So you've got some options there. And let me show you that last one that we haven't seen here. It's going to be oryx. And it also has the use of red. It's negative. That's pretty standard. If you want to hit solve, that gets that equal sign in there. But it also has the values on there. So it's really your choice as to what you want to do with your students. And that's it. They're simply they're simply representing different equations. That's the ask right here. And so it's going to be a really light ask, but it's going to be engaging because they've got, things to do. If you want, you can have students copy these equations that you display and the representation of the algebra tiles into their math journals for future reference. Because if you know they're struggling with representing them, if they have a few exemplars that they created, then that's going to be easier for them to reference in the future. You can have them, you're not asking them to do that in the base activity, but you might want them to, create zero pairs and actually solve for x. You can give them verbal descriptions if you really want to get difficult. Get some of these verbal descriptions from the round table. Can they create algebra tiles from here, which is what they're asked to do right here, but they're drawing it there. Can they do it on a digital tool right here? And then NCTM actually has algebra tiles, but here's what's different. You're going to use these tiles right here. If you want, right, you can build one right here. But here's the interesting thing is, so let's say that's going to be a negative, and if I want to make that positive, you would uh, do this right here. So these are your two tiles right here. Here's the interesting thing. You're actually not just building just anything. You're actually needing to build this negative 4x minus 4 on this side, and then negative 5x plus 3. It's got a self-check, right? It didn't make it this time because I didn't get it correct, but I would need to, make this negative 4x. I'd need to bring out, 4 of these. You can do it vertical, horizontal, whatever. And then I would need minus 4 right here. And then if I do that, that's correct on one side, but it's not correct on the other side, so I'm still not going to get that. And then you can solve it. So that's a different activity that actually has a self-check, so that's very nice. Our next activity is called Write the Equations. Very simple. It is based on the need that I saw from this particular problem right here, whereas only 25%, and honestly, a lot of that was just guessing most likely, could accurately create an equation and then solve it. And the difficulty there is how do you write an equation from a verbal description? Once you get just a plain equation, most students have a strategy on how they can attack that. So what we're wanting here is we're wanting some index cards, put students into groups of 2 or 3. You can print and paste, on the index cards. You can write them out, your choice on these index cards. And I give you some star examples here. I've got those right here. These are from STAR, so this is every single verbal description that I was able to find on any released STAR item from 2016 all the way up to 2023. So these are going to be your examples. Those are going to be on the index card. And then the group's activity is to take the index card and then write a one variable linear equation that represents that word problem on the back of the index card. So one side has the verbal description, the other side is what the group is writing the linear equation for. And then maybe it's a race or it's just a timed activity. They just do as many as they can in the allotted time, and then you review your answers in a class. Once again, the real cognitive lift here is to create the actual linear equations. You don't need to get a grade out of this. You don't need to get a grade out of any of these activities. You wanted to make it, remember, active, playful learning, fun and engaging, and it's kind of a low stakes, no stakes. You review the answers with the class. Now, you can repeat this later with additional examples. And so I've got on this exact same one, if you scroll down, additional examples that are similar. So basically what I did is I just plugged all of these into ChatGPT and asked them to create something similar. So it's the same type of problem. If you wanted to do this activity again, each number it corresponds with the type of the one above. So those are linked. If you want, you can have, after a designated amount of time, groups can pair up, and then they might not have all done the exact same ones because there was a lot of options there. It might be a short amount of time. But if they found any problems that they both solved, you can have them review their equations to see if they got the same equation. These are great for self-review. So gather them. You might want to proofread them to make sure that they're good, or have the students do a good job of checking them as you review the answers. But this is a great self-review. Students can do this on their own if they're, you know, done early and they want to kind of look over something, get ready for a test. And then what we're thinking about on this last bullet point here is, if you want, you can do like a kind of a quadruple memory match is what I'm calling it, right? So you have the verbal description on one, and then you have a whole bunch of extra index cards. Instead of writing the equation on the back of that first one, you actually write the equation on a second index card. Then they draw algebra tiles on a third index card, and then they write the solution on a fourth index card. That creates a book or a set of four. Then you could do a memory match, right, where any of those two would work together as a match. You can play something like Go Fish. I mean, there's all different kind of options when you get those sets of four. So that could be something that you could do. And then finally, this will get students up and moving. This is a solution relay race. You're going to place students into three teams. For each team, you're going to have a linear equation problem randomly written on index cards or on the board covered up with like a sticky note, your choice. And so these are just some raw linear equation problems. So I just put those up there. You can use those also for the earlier activity with the algebra tiles if you wanted to use those. Those are linked right there. And it's just a basic relay race. You know, team members run up to the board one at a time. They solve the problem. When they complete it, they run back to their team, tag the next person. You see who gets the most in a set amount of time, who completes all the problems. It's just a basic relay race, but you're trying to make it a little bit more interesting, right? So they're trying to solve these equations. And as you can notice here, the idea here is that for the most part, right, there is a few fractions, but you should be able to do this without a calculator. We're not necessarily dealing with decimals and getting really intricate like that. We're thinking whole numbers or things that can easily be turned into a whole number, right? If you multiply both sides by 9, you can get rid of that fraction. So that's the idea behind that. If you wanted to add a layer of complexity, two people from each team run up to the board simultaneously, gets a little bit more engagement. The first student solves the problem, and then the second student has to check the validity of the solution using substitution. The reason I keep bringing back to that is because students can check their work on the STAR test. They don't just have to guess on an answer, and some students don't have that stamina to, once they solve a linear equation problem, actually substitute it back into the equation to double check to make sure it works. So I'm wanting to hammer that point home. If you need to, you can provide calculators, and instead of solving the problem, right, students might be asked to draw an algebra tile representation. Maybe that's the ask. So those are just some ideas that we can use to help students learn a little bit more about TEKS 8.8c modeling and solving one variable equations with variables on both sides of the equal sign.